Hi, this is Dr. Syed from India. Today I am going to teach you about NEBOSH IGC Elemental 11 Part D, Plant Startup and Shutdown Hazards Controls. Startup and Shutdown Safe Practice. Startup or shutting down procedure is the most hazardous part of the operating system. The reason behind this is the system is constantly working until it reaches its optimum level. Though that is a level of normal operation or a peak level of being fully shut down, these energies may be pressurized. There are many hazards associated with safe startup and shutdown procedures. In the startup and shutdown process, system must be able to withstand due to the changes occur during this process. It's most important that all personnel involved in either of these operations and work as a team from a predetermined operating procedures. These procedures are kept fully up to date and should take into account about all potential eventualities associated with startup or shutdown. Safe startup and shutdown operating procedures and instructions. It's essential that the operator should have the operating procedures available at all times for the purpose of reference. The operating procedure document should be stringent and the following points should be observed more strictly. The document should not have more easier or dangerous alternative procedures other than the documented in the operating procedure. There should be a review procedure system which can ensure that the operating procedures are up to date and to detect any type of errors in procedures which can be corrected quickly. The personnel involved in the operation process should also be involved at the operating design stage. Operating procedure should also include the information about the requirements and the use of personal protective equipment when carrying out the operating system. The starting procedure should include the following: the overview of the work to be done, identify the risk exposed to the operator as per the risk assessment of the work. Any other prerequisites should be clearly stated in order to check and ensure that it's safe to proceed further with the procedures. Every operating procedure document should have a starting date and an expiry date. Each document is valid for 6 months from the date of given on the document. The document should be very clear, stating that which procedure may be applied to which situation. There should not be any doubt with an appropriate method of coding with each procedure. The document should give more clear information and ensure with different subtasks are listed under separate headings to differentiate them. The document should be written in a language which is more simple and familiar to the operators who are performing the tasks. Ensure that the terminology used in the document should be consistent with that used on controls or panels. We should ensure that any cautions, warnings or notes are put immediately before the instructions. Always ensure that any shapes, symbols and colors which are used for graphics should be consistent and conform to industry standards. It may be common that a plant or process system may produce additional hazards than they expected when it started up. The hazards may be associated with normal process operations. Some of the examples are mixing of air and hydrocarbons which are potential for explosive mixture, and the mixing of the oil and water. The temperatures below the freezing point with the potential for any water present in the system to freeze. The example is the formation of hydrate with pipework and valves. Any equipment subject to over or under pressurization and to thermal or mechanical shocks. Corrosive and toxic fluid and gases. Before the startup of any process, it's necessary that all safety critical elements are fully operational and they may be dependable on to operate if a problem occurs. The safety critical elements SCE are dependable on the particular process system, but these SCE elements may include the following to protect the failure of mechanical equipment. The SCE elements can protect the following: the fire and gas detecting system, the emergency shutdown system, the vent and blow down system, high pressure and low pressures, the protection system of fire deluge, the emergency power supply system, and the flare. Safe startup and thermal shock. One of the major hazards in startup procedure of the plant is the thermal shock. These hazards can have the potential to create a catastrophic event if any of the critical components get failed. It's necessary to find out the causes of failure and why it's catastrophic. When the material heated due to the rise in temperature in the process, the material properties get significant changes in temperature. This results in the expansion of material at different rates within a limited area and cause a crack or failure. Thermal shock is a phenomenon where a material is exposed to a sudden and significant change in the temperature. This results in the material to expand at different rates within a limited area, which cause a crack or failure. For an example, if you pour boiling water or material in a glass pot, the glass pot breaks due to the inside molecular structure of the glass, which expands more rapidly than the outside molecular structure of the glass, and it causes it to break. The same effect can also be experienced with the metal pipe. In the oil and gas industry, if superheated steam is introduced in a pipeline which has not been warmed previously, this may cause thermal shock in the pipeline and result in a pipe fracture. In other terms, thermal shock is a mechanical load caused due to a rapid change of temperature at certain point. This can be also extended to the case of a thermal gradient, which can make the different parts of an object that can get expanded. This expansion can be seen in the stress and strain diagram at some point. This stress can exceed the tensile strength of the material, which may cause a crack to form. If the crack gets propagated through the material, then it will cause the structure to fail completely. Thermal shock can be controlled by the following. By gradually introducing the steam or warm water from a lower temperature and thoroughly warm up the system before the application and use. Systems should be designed with expansion loops like expansion bellows so that the bellows can expand due to the thermal changes and without compromising the integrity of the system. The used base material should have greater thermal conductivity and high strength of material to reduce the coefficient of expansion of the materials. Procedure of a startup operation. Before startup operation, all safety critical elements SCEs, they are inspected to ensure that they are operational. All the pipes and drains are opened during the activities of maintenance or again closed off as required. All the instruments are calibrated and replaced with good one if they found error, and confirm that they are in good working order. All spades, spectacles, blinds have to be removed or turned on to their correct operational positions. Startup operations consist of some standards practices to ensure that only essential personnel are allowed into the production area when the startup operation is ongoing. The procedure consists of a joint operation carried out both the control room operators and the operators on the platform. The whole startup operation is a cooperative operation between the above two groups, where it's essential that close radio communications are maintained between the control room and the plant operators. The operating procedure document is thoroughly checked and get ensured that it's up to date, and the copies of the same documents are available by all party members, including those physically on the line as well as to those in the remote control room. Then finally, when all the preliminary procedures are completed satisfactorily, then the production train is proceeded and lined out as per the standard pre-startup procedure, which is set out in the operating procedure document. This procedure consists of the opening valves by the operators on the system in a specific sequence. But though the sequence is critical, it's not just left off to the operator to follow the operating procedures document. But in this case, Each valve is fitted with a unique specially designed key. In this system, only when the correct valve is set up to the correct position, then only the key will be removed to open the next valve in the sequence. The key is designed in such a way that it will only fit to the correct valve in the sequence. This valve settings procedure is repeated until all the valves are put into their correct positions and in the correct sequence. This will result to perfect operating procedure in the event of a highly critical operation. As soon as all the valves have been set up, then the final key will be taken from the last valve and allow the operator to open the isolation valve. Then finally, this allows the product to be introduced to the system and the process becomes operational. Valve interlock system. The following example describes the switchover from one pipe to another pipe. In this system, mixing of different medias will be avoided and a perfect flow system can be streamlined. Here, the media is flowing in the right pipe when the valve is open. This is shown by the upper key shaft A in red color. It's impossible to operate the valve now as it is locked. The lower key B in blue color is trapped in the shaft. The valve of the left pipe is closed, so no media can flow in this pipe. An authorized person can only insert the key A, that is in red color, into the right interlock. The lock is released and the operator can close the right valve. As soon as the valve is closed, the key B in blue color can be removed. Upon removal of the key, the valve is locked again and can't be operated. The media in the right pipe can no longer flow on. Then the operator can insert the key B in blue color into the left interlock. Now the lock will be released and the operator can open the left valve. After opening of the left valve, the key C, that is in green color, can only be removed. Now the media will flow in the left pipe. When you remove the key, this valve is locked and can no longer be operated. We can set up this interlock system with a number of valves by applying this principle of interdependent keys and locks. The application of this system can be adapted to some specific processes. Hence, the interlock system is applied to valves to ensure a fail-safe system of control to ensure the correct opening and closing sequence of the process critical valves in a system to ensure safety. The valve keys. In the system, the valves get interlocked as well as the key. The keys are made up of stainless steel. The individual coding can guarantee to the highest level of operational safety. It's not possible to make duplicate keys like padlock keys due to the special design and coding of each key. The coded keys have been designed with a thought of ergonomics where we can use the keys without any difficulty. even though we wear heavy-duty safety hand gloves. The coded keys can be inserted into the lock by either directions, as there is no fixed position of the key. It's quite enough to insert the key just a few millimeters into the lock to know that the inserted key is a correct match of the key. Color tagging of the key can make it easy to match the keys with the corresponding interlocks. The colors and the features of the key can allow us for a speedy workflow. The line can be considered as an on-line only when all optimum pressure levels, temperatures and flows have been established. When this level of operation is established, then the control room can take over the operations and run the operations automatically. Shutdown operations. Shutting down process is also equal as hazardous as a startup process. The personnel involved in this process should work as a team with a predetermined operating procedures, which will have all the possible eventualities associated with shutdown process. We have gone through all the startup process in which the procedure is carried out in a very slow manner. If you have more than one well, each well is taken into offline by closing its wing valve. In the shutdown operations, we should ensure that the gas flow has been stopped when all the ancillary system will be slowly get down to shut down and then isolated. In this process, the safe procedure is that the production line to be shut down and isolated by closing the valves in the reverse order to the procedures in which it was opened. Further, the key system on each valve can ensure the correct sequence of order to be followed. If you consider a shutdown at a refinery, this procedure may have a number of phases as follows. Number 1, the first process is the cooling and depressurization of the process. Then, reducing the levels of flow and process liquid and removing the residual hydrocarbons if any available. Then, inerting the gas and gas freeing the system and removing any corrosive or toxic materials from the system. Then, removing the water from the system. Then finally, isolating the process pipe work. Further, it's important that any fired heater should be shut down to reduce the heat input in the process. The flow of the product should be reduced gradually and finally it will be shut off. The excessive pressure emanating from hydrocarbon gases should be released into the gas collecting system. My dear students, this is the end of NEBOSH IGC Element 11 Part 2D Plant Startup and Shutdown Hazards Control. Work safely, live safely. Thank you very much.